Hello, Algebra 1. Today we're looking at Chapter Unit 6, Lessons 8 and 9, which is equivalent quadratic expressions for Lesson 8. So, example 1, diagrams of products. Explain why the diagram shows that 6 times the quantity 3 plus 4 equals 6 times 3 plus 6 plus 4. And draw a diagram to show that 5 times the quantity x plus 2 equals 5x plus 10. So for number 1, the whole diagram shows that the product is 6 times 3 plus 4 because this green box would be 6 times 3 and then this blue one would be 6 times 4 to get the area of them. And then draw a diagram to show that 5 times the quantity x plus 2. So if we do this, and then we put a 5 up here, an x here, and a 2 here. Right here would be 5x, and right here would be 10 because you take this 5 times the 2 and this 5, or the x and the 5 times the 2. So example 2, applying the distributive property to multiply out factors of or expand 4 times the quantity x plus 2 gives us 4x plus 8. So we know the two expressions are equivalent. We can use a rectangle with side lengths x plus 2 and 4 to illustrate the multiplication, which is to the right. Number 1, draw a diagram to show that n times the quantity 2n plus 5 and 2n squared plus 5 are equivalent expressions. So here, this is what the diagram should look like because you would take your n times your 2n and your n times your 5, and you'll get these two areas. So for each expression, use the distributive property to write an equivalent expression. If you get stuck, consider drawing a diagram. So for A, you take your 6 times your 1/3 n, and you'll get 2n, and then plus, and then your 6 times your 2, and you'll get 12. Okay, B, p times 4p gives you 4p squared, and then your p times your 9 gives you plus 9p. C, 5r times r gives you 5r squared times your 5r times 3/5 gives you 3r. And then for D, this one is just on the back, so you'll still do it times each one, and it will give you 0.5w squared plus 7w. And you can draw diagrams too to help you out. I didn't, but that is a good way to do it too. So example 3, number 1. Here's a diagram of a rectangle with side lengths x plus 1 and x plus 3. Use this diagram to show that x plus 1 times x plus 3 and x squared plus 4x plus 3 are equivalent. So filling this out, we get x squared here, 3x, x, and 3. And then writing that out, you get x squared plus 3x plus x is 4x plus 3. So that is equivalent. And then number 2, draw diagrams to help you write equivalent expressions for each of the following. You don't have to, but working this out, this one would be x plus 5 times x plus 5, which is x squared plus 10x plus 25. This one you would take 2x times x and times 4 which gives you 2x squared plus 8x. Okay, the next one gives you 2x squared plus 7x plus 3. And then the last one will give you x squared plus mx plus nx plus mn, or x squared plus m plus n times x plus mn. And then number 3, write an equivalent expression for each expression without drawing a diagram. And so for a, we would get x squared, taking x times x, then plus 8x, because you'll take your x times 6, and then your 2 times your x, and then you'll add those together, and then plus 12 by taking your 2 times your 6. Okay, and then for b, we'll get 2x squared by taking your x times your 2x, and then plus 20x by taking x times 10, and then your 2x times your 5 and adding those together, and then plus 50 by taking your 5 times your 10. So for your summary of lesson 8, multiplying x plus 2 and x plus 3 gives the area of the rectangle. Adding the areas of the 4 subrectangles also gives you the area of the rectangle, which means that x plus 2 times x plus 3 is equivalent to x squared plus 2x plus 3x plus 6, or x squared plus 5x plus 6. And then notice that the diagram illustrates the distributive property being applied. Each term of one factor is multiplied by every term of the other factor. So it's basically saying you'll multiply the x to each term first, and then you'll do the 2 to the other terms next, which will give you this next step right here. And then this just shows that you're doing this first step, so x times each term, and then the second step, which was the 2 times each term. And then you just multiply that out and add everything together. Now we will look at lesson 9, which is standard form and factored form. So example 1, solve each equation mentally. So just looking at it, we see that there is a 40 on each side. So we'll just subtract one of them to both sides. And then doing that out, they both cancel, and then you'll get negative 8 equals n. Okay, going to the next one, there's a 25 on each side. So again, you'll just subtract one of them off, and they're both positive, so it cancels out again, and you'll get negative 100 equals negative n. And so you have two negatives, so it would be positive 100 equals positive n. Okay, the next one, there's a 3 on each side, so subtract that. So you get negative a half equals n. And then for the last one, there's a 72 on each side, so subtract 72. Those cancel. You get negative n equals positive 6, so divide by negative 1, n equals negative 6. Looking at example 2, show that x minus 1 times x minus 1 and x squared minus 2x plus 1 are equivalent by drawing a diagram or applying the distributive property. And so drawing a diagram, we have this. So this would be x squared, negative x, and 1. And so the sum of the products are x squared minus x, well, plus minus x, and plus 1, which equals x squared minus 2x plus 1. And then number 2, for each expression, write an equivalent expression. And so for A, we get x squared, and then plus x minus 1. These two cancel out right here, which gives us x squared minus 1. And then for B, we will get x squared minus 2x plus 3x minus 6, which equals x squared plus x minus 6. And then for C, if it helps you, write it out like this again. And then we will get x minus 2x minus 2x plus 4. Oh, this should be squared. And then that will give us x squared minus 4x plus 4. Looking at example 3, the quadratic expression x squared plus 4x plus 3 is written in standard form. Here are some other quadratic expressions. The expressions on the left are written in standard form, and the expressions on the right are not. And so, number 1, what are some characteristics of expressions in standard form? Some example responses would be that the standard form always has an x squared term. It does not need to have an x term or a numerical term. It also is not important in which order the terms are listed, and the standard form shows a sum or difference of terms. Number 2, x plus 1 times x minus 1 and 2x plus 3 times x in the right column are quadratic expressions written in factored form. Why do you think that form is called factored form? So one way to put it would be that it is a product of two factors. Each factor could be a variable, a number, or an expression with a variable with no exponent and a number. For the summary, an expression in factored form can be written in standard form by expanding it, which means multiplying out the factors. And so, to represent x minus 4 times x minus 1 with a diagram, we can think of subtraction as adding the opposite. And so, looking over here, to do x minus 4 times x minus 1 using the distributive property, you take your x times each term, and then your negative 4 times each term. And then again, this is just showing what you just did in this step before, taking each term times the other, and then multiplying everything out here, and then this is just putting like factors together, and this would be your answer.